Hey, can you map this later on my assignments at one?
Read the email
I was just
wrong.
getting this news.
I was like, Brian did point that out, that I said, hey, see y'all next week, but.
It was only one day. Yeah.
I was so confused, I was like, so what's
I mean, it says class cancel 11/13.
Yeah.
I'm like, I know which day.
We're just like, it was just me and her at first. And I'm like, where's
Hello?
everyone?
But yeah, most of the time, like MJ's already here.
Well, they can watch the video. All right, so as for today. All right, we are going to hopefully finish up chapter 7 here. So these last two sections are the most complicated, but then also the most widely used and definitely in Math 1400 college algebra. So this one, all right, first we're talking about complex rational expressions. So complex rational expressions is when you basically have fractions within fractions. So notice I have a fraction plus a fraction here and a fraction minus a fraction here. Because I have a fraction individually in the numerator and a fraction individually in the denominator, that is what they create an entire big fraction, right? There are 5 total fractions in that expression. That means that is what's referred to as a complex rational expression. So we're going to look at the techniques of how to simplify these. The first technique is by division. Basically, that means look at just the numerator, then just the denominator, simplify those individually, and then just do leave it, change it, flip it. So for this one, so just, all right, looking at the numerator, that means I have 5a plus 1a. 5a over 2a plus 1 over a. So with that, then I identify the common denominator among 2a and a. So what's the common denominator?
A.
No.
It's just 2A.
2a. All right, it's gotta, remember, least common denominator, it's gotta be bigger than the smallest piece there. So that means this one, nothing happens. But for this piece, I need to multiply this one by 2 over 2. Once I have that piece, then I can put it all over one entire fraction. And then it's just 5 plus 2, 7. So dealing with just the numerator, all right, completely ignoring what's happened in the denominator. For the denominator piece, all right, so now we're going to look at the denominator. I have 1 over 4a minus 5/6. What's the common denominator, all right, between 4a and 6?
2A?
It's got to be at least as big as the smallest part. So start with 4 and 6. What's the common denominator between 4 and 6?
24. 12. 20, 12.
24 is a common denominator. Typically, we're kind of looking for the least common denominator, right? The smallest. So it's always think of the small numbers. Okay, so 12. And then between a and no variable? Just basically like we had 1 over a plus 1 over 1. What's the common denominator? A. Remember, you have to add the variable in, which means this one needs to be multiplied by 3/3. This one needs to be multiplied by 2a/2a. We're creating the least common denominator. Now, as Anya pointed out, if you're having a hard time thinking of the least common denominator, remember, the easiest way to create a denominator, multiply this denominator by this denominator, 24a. That creates a denominator, just not the least common denominator. All right. The problem with that is when you have 4, 6, 12, 3, and a 2 in there, you have to multiply all those together to create it, right? So even though like 12 would be the least common denominator. Okay, so that becomes 3 all over 4, 12a. Minus 10a all over 12a. Once you have a common denominator, all right, then, all right, you can put it all over one fraction. And those don't combine, that just becomes 3 minus 10a. Once you have that, now notice, all right, what we have converted this into. I basically just added two fractions individually. Then I have a single fraction divided by a single fraction. Once I have that, that's leave it, change it, flip it. That is multiply by the reciprocal. And then that looks like basically what we were dealing with last week. All right, multiply straight across, but remember when you're multiplying straight across, we can do a little bit of canceling because I basically just have some fractions, right? I see a 12a and a 2a there. That means that becomes a 6, that becomes a 1. Brittany, okay?
I was like, oh, 6.
12 divided by 2 is 6. A divided by A is just 1. So those actually can cancel. Be aware that we could write that, I mean, you can write this out as 12 times 7 times 12a and then 2a times 3 minus 10a to give yourself another step, because it does go over. When it's two fractions being multiplied, it's really just one fraction. And then I could do the cancellation here, which is the same. Because things are being multiplied, I can cancel. When things are being multiplied, you can cancel. I cannot cancel with this 10a here because that is within a subtraction. That means that is one entire piece. All right. The only way to cancel that is if I had a 3 minus 10a on top. Or 6 minus 20a, something like that. All right, let's look at another one. This is a complex rational expression. Okay, people are often confused though, because in the denominator, I just have x over z, or x times z. But remember, whenever you have an integer, right? And sometimes we have to make it worse before it gets better. That is an integer in the denominator. That is a whole number, but I actually need that as a fraction. So how do I turn x times z into a fraction?
Can you just put it over 1?
Put it over 1. And actually that'll complete, all right, my complex rational expression. Then we do the same thing. In dealing with just the numerator. What is the common denominator among just the numerator? XY. And this one is that technique where, oh, look, I have Y, I have an X, multiply them together. That is actually the least common denominator, which means for the first piece, I'm going to multiply it by X over X. For the second piece, I'm going to multiply it by Y over Y. So the whole idea of simplifying using division is I'm just adding two fractions. That's all this is. All I did was add two fractions together to create a single fraction. Then I do the same thing with the denominator, but that one's pretty easy. Let's see, what's the common denominator among the bottom? Oh, it's done. All right, there is nothing to do. Once again, now I have a single fraction divided by a single fraction. Leave it, change it, flip it.
Wouldn't that second fraction be 1 over XZ if you're flipping it?
It is 1 over XZ. I was getting all excited to cancel. Which becomes, all right, X times Y times Z, all right? And then I can see if, oh, whoops, except this shouldn't be here anymore. All right, with X cubed, let's put a 1 in there. X cubed minus 5Y in the numerator. And then I can simplify all that together. And the important part here, okay? Can I cancel this X squared with this X cubed? No, it is a cross addition, all right? Which means we cannot cancel that. So simplifying by division, right? Deal with the numerator, deal with the denominator, then leave it, change it, flip it. Most people, all right, actually prefer that method. However, there is another approach. Same thing, I have a complex rational expression. But sometimes you run across a situation where, well, all these denominators are actually kind of nice to deal with. I have X, 2X, 3X, and 4X. So I look at all the denominators together. What is the common denominator among all of these? Almost. Almost. It's not just 12.
X.
12x. Don't forget the x. All right, 12x. All right. We still have variables in there, right? We can't just drop them. So instead of dealing with just the numerator and just the denominator, we can deal with the entire fraction all at once. We do that by multiplying by the common denominator over the common denominator, right? So multiplying 12x over 12x. That's the common denominator of the entire fraction. In order to do that, though, since I have so many fractions, I need to turn that 12x into a fraction. And then All right, just so we can see, what's really nice about this is so much stuff is gonna cancel. So I'm gonna write this out. It's gonna get a little worse before it gets better. I need to multiply that 12x into every single piece. So once I multiply, all right, that 12x over 1 into each of the 4 pieces. Now I get to do a ton of canceling. And so this is essentially what we did slowly above, but we basically get to do it all in one step here. So just like we did before, 12x divided by x. 12. That's a 1. 12x divided by 2x. Brittany.
Wait, 6.
6, right? So all we're doing is just each piece. 12x divided by 3x. 12x divided by 4x. Notice I'm just doing the cancellation with each of these because they are multiplied. So I can cancel where it's multiplied. Now notice, look at all the denominators. Go ahead, Brian. Not just the same, but they're 1. When it's over 1, does that mean you have a fraction? No, you actually have an integer. So the whole concept of this is the fraction goes away in one step. I'll write this out slow one more time. That's what that ended up becoming. So let's see, 12 times 3, 36 plus 6, 36 plus 6, 42. 4 minus 9, -5. And oh, look.
So this is something you can do to the problems above too. It's not.
Absolutely. Now, be aware, the answer will result in the same that we got there, all right? So the fact that this one ended up all the variables canceled, that's just coincidence.
Okay.
Okay, but we can absolutely, whatever technique you have, when you have a complex rational expression, okay, you can either simplify using division or simplify with multiplication. Whichever preference. Now, be aware, most people actually use division, all right? But because multiplication is really nice if you see something in it. Like I see all those denominators and I see they're all really close. That's when I say I want to do multiplication. When I look at denominators, and they're all not close, this one actually could have lended itself to multiplication because I see the common denominator among all these is 12a. All right. That bottom one, absolutely don't think I want to do it there because I see a lot of different denominators and I kind of see a lot of variables and it looks like a mess.
Okay.
But does it work every time? Absolutely.
Whatever's easier.
Yes, whatever is easier for you, because the directions are the same every single time,
So fine. Okay.
right? It doesn't say simplify with this technique or that technique, it just says simplify. To that end, we are finally going to change the directions, all right? Up till now, all these problems have said simplify. Now we are finally going to solve, right? Because what we actually do is solve. We like to find x equals a number, right? That's what's the most satisfying. I want to get an actual answer, all right? I'm not just simplifying this to make it easier. We have to go through all that simplification because if you can't simplify, solving is very tough. Create, and basically we have the same techniques basically that we just saw. Either you simplify by creating a common denominator or simplify by trying to eliminate the common denominator. But it all starts with identifying the common denominator. So, and then don't forget, one of the biggest things is we have to check our solutions and we have to be a little more wary here because if we have denominators in the variable, we have to make sure that we don't have solutions that cannot exist. Right? Because you cannot divide by what number?
0.
0, right? When you divide by 0, that results in undefined. So we have to make sure that that doesn't happen in these equations. So 6, 8, and 12, what is the common denominator?
24.
It is 24. But, all right, if we got confused, 6 times 8 times 12, that is a much bigger number than 24, right? But if you're stuck on denominator, if you just can't figure it out, that's how you identify it. Or that's the fast way. All right, so the best approach, multiply the left side and the right side by 24. What did we said 24. Multiply the left side and the right side of the equation by the common denominator. It's gonna get a little worse before it gets better. And I like this technique the best. Now, the other technique is I could just create the common denominator, that being 24. This technique is nice because notice what's gonna happen, 24 and 6. Yes, you're absolutely correct. I'm just doing the numbers though, right? 8 and 24 and 12 and 24. Once again, notice what happened to all my denominators. They're all 1, which means, and this always works for solving problems. So we saw above, when you're simplifying, like sometimes the denominator will go away, some like, depending upon if you do fractions. But if you multiply by the common denominator, you will eliminate the fraction in one kind of long step. So we end up with 4x minus 3x equals 2. Oh, well, gosh. Doesn't get much easier than that. 4x minus 3x. X, just making sure we're on it. And oh, look, x equals 2. That's our answer. So multiplying by the common denominator eliminates it all very, very quickly. But we're not always going to have numbers as our common denominator. So we have to create common denominators with polynomials. What is the common denominator for this equation?
+2.
X plus 2, all right? The big part here with an integer 1, if I have 2 other fractions, what should I do to this 1?
Turn to x +2 over x +2.
Yes, or to start, 1 over 1. Turn it into a fraction and then you're absolutely correct. I need to create the common denominator there, which means I'm going to do x plus 2 all over x plus 2. I need to turn it into a fraction, and you're right. I could immediately skip that step, just slower. So we turn 1 into 1 over 1, then create the common denominator among everything. Now, this one, we went the other way. So the last one, we went basically doing multiplication. This one, we went by creating the common denominator. All right, and I want to show the difference basically because what's going to happen? All right, what do we have? 4x plus 2. And a lot of people do it this way. Because basically I still have, all right, my fractions, because I created a common denominator and I basically have to take my fractions with me instead of eliminating them. But once you get to this step, you can eliminate your fractions. I have a fraction equals a fraction. What technique do we use to solve that equation? And it might be easier to recognize like this. How do you solve that? This guy. Not subtraction. So most people like have this on the tip of your tongue. When I say it, you're gonna know it. Cross multiply, right? Once you have fraction equals a fraction, all right, you cross multiply. All right, so finishing this guy out, right? This becomes 5 times 10 equals 7 times x. And then, yeah, so then I have 50 equals 7x divide x equals 57s. So a lot of people are really familiar with that. The nice thing about doing cross multiply on this one, if I have an x plus 2 on both sides, we have to do an additional step. This is why I don't like this technique. Divide both sides by x plus 2. That cancels there, that cancels there, that cancels there, that cancels there. And oh, look what we end up with. 4x plus 2 equals -6. But the concept of what you're doing is cross multiply. But you have to do an additional step because you have variables all over the place. And then from here, yeah, -2. Now this one's really fun. Okay, so we solved it down and it looks like x equals -2 is our answer. But we did something important, and this is why we identified it right here. In order to solve this down, I had to divide by this. Okay? Anything divided by itself should just cancel. But x equals -2. -2 plus 2 is, which means I divided by 0. Which means the only solution this can't be is -2. So this is a really fun one. Here's why. All right, so if we got x equals -2, but x cannot be -2, then what's the answer? Does anyone know what's left? You guys remember seeing this? No solution. I think that's really fun. Most people really feel dissatisfied by it. I was like, because they're like, whoa, I did all that work just to say it can't be that number, so then the answer is no solution. Kaylin, you okay?
So like, where did we divide by 0? Was
Right
it-
here, right here. Because if I put -2 in here, -2 plus 2
Oh.
is 0.
Check it, okay,
When it in the check.
okay.
Yes, no, we're complete.
That's not 0, obviously.
Yeah, no, we're completely good until here, but you have these ones, you have to do the check. Now, be aware. From the beginning, did I know -2 cannot be an answer here?
No, not until you solve it, check it.
No, I definitely did.
Oh.
-2 plus 2
Oh,
is 0. So you can identify what cannot be a solution immediately. So some people like to do it at the start, but this one I wanted to build the suspense, so we did it at the end. But I knew from the beginning, the only thing this can't be is -2. And from here on out, let's do that at the start.
So if that were to be on a test, can we automatically just circle that and be like, no solution?
Well, but what if we got x equals 5? What if we, when we solved it all the way down, we got x equals 5?
So,
5 is a solution if it's solved down, and to that end, let's solve the next one.
It's just a coincidence that both of them.
It's that one that it can't be that one. So let's start this one. What can x not be? On 0, right? Because if I put 0 in there, we know x cannot be 0. But when I solve this down, I have a feeling I'm not gonna get 0 as the solution. You won't know until you solve it all the way down. No, there's no shortcut there. Sorry, Maddie.
okay,
All right, so the least common denominator for this guy is what?
Yeah.
3x. So let's multiply, and because this is the faster way, identify what it is, all right, and then we know.
so I don't understand how you find that.
The common denominator. So there are 3 fractions here. 2 over 3x. 1 over x and 10 over 1. Those are the fractions, all right? So I turn that 10 into a fraction. I have to create the common denominator. So start with the numbers. 3, 1, and 1.
So it's the highest number.
Well, not always, 6 and 8, right? The common, this, back to our arithmetic, right? Always think back to the simple thing, 1/2 plus 1/3. Right? This one needs to be multiplied by 3 over 3. This one needs to be multiplied by 2 over 2. So I'm just doing the numbers. And then it works the same with variables. X squared plus 1 over y plus 1 over x. I was like, this guy is just x times x. So I look at each one and I say, what's missing? This one, right? When I did 1/2 plus 1/3, this one needed to be multiplied by 3. This one needed to be multiplied by
It'd
2.
be y, 2x, and x and y. Right?
Almost x squared. No, x times x is x squared, right?
Yeah.
But yes, exactly. Yeah. So the common denominator is x squared y. This one needs a y. This one
So it's all of them combined.
needs an xy, but notice this x at the end is repeated. So this one doesn't come into the others. This one needs an x and a y. We remember all the prime factorization we did? This is always what you do to identify what's missing, right? And what needs to be added. You just, this is arithmetic. And we just stepped it up a touch with the algebra, but it's still arithmetic, right? Because you don't want to just multiply them. This is what, right, Anya was like, oh, you could always do it by multiplying. But when we looked at even that one number, where was it? 6, 8, and 12. 6 times 8 times 12, I can create a common denominator every time. But the least common denominator is way easier to find.
So if you accidentally don't use the least common, but still a common denominator, will you just have to reduce down?
You have to reduce it at the end. Absolutely. Right? So we let 2 times 2 times 2 and 2 times 2 times 3. So, right, here's 6, 8, and 12, adding these up. 6, 8, and 12. You do the same thing. What's missing in this one that's in all the rest? 2 2s, right? You just look at each one individually. So this one needs a 4 over 4. What's the middle one need?
A 3.
A 3. And what's the last one need? Another 2. Algebra is not that hard. Everyone gets overwhelmed when you put variables in there. Go back to numbers every single time. That's why I started with this problem. Because common denominators are the same arithmetic through algebra. But everyone sees a variable and panics. But it's the same. Where were we? Okay, so the common denominator here is 3x. I'm going to multiply that through. Tangents here. And then once I multiplied it all the way through, and I like to, now you can do this faster. I like to do it slow so I can clearly see my cancellation. But I have a lot of people that like go from that top step to the next step down, which is absolutely fine. Whatever you can successfully skip, fine. If you start messing up, do more steps. All right, so I see 3x and 3x. I see an x and 3x, which leaves a 3. And oh, look, 1's nothing cancels, so that one's fine. And then I always know this worked because if everything canceled, all right, I should always end up with all 1's in the denominator, all right? Otherwise, I did not find the correct denominator. And then that leaves 2. 1 times 2 is 2 plus, all right, 3 times 1 is 3 equals 3x times 10. And then a couple simple algebra steps. Now, here's the big thing, right? So we started out, x cannot be 0. Is x 0? No, so that is the answer, all right? Only when you solve it all the way down and the single value or multiple values, could be multiple values, that it cannot be, do you end up with no solution. So it's actually hard to get no solution, okay? That's why this one I was saying is such a fun one, because it's actually hard to end up with no solution, all right? But they're super fun when you point them out, when you identify them. She's like, oh my gosh. I was like, oh, I did all that work just to get no solution. Yes, Brian.
What do we do if all of the so what do we do if, let's say, all the denominators are just 2? And instead of the 1, what do we do if they're, let's say, 2?
Two? Like
So,
like numbers? What do we talk about?
so if you go all the way down to the very bottom one, the one that we just did, instead of them all being 1, let's say they're all 2, would we do it the same?
Well, if they all end up as 2s?
Yeah.
Well, 2 times 2 would be 4. You would end up with fractions still in this step is what happens. And that was the previous one I did. You can do this all the way down with fractions, but at some point, you're gonna have to cross multiply, right? This is kind of the argument between doing simplifying with division or simplifying with multiplication. Basically, what we did here, this is simplifying with multiplication. What we did here, this concept, that's simplifying with division. And if you simplify this way, that is you create common denominators instead of eliminate common denominators, you will have to do a cross multiply step to eliminate them, which is fine. All right. It's just whatever your preference. Does it work both ways? Of course. I was like, however you approach it, I like to get rid of my fractions. I want to eliminate fractions, and most people, what I usually hear is everyone hates fractions, which is why I emphasize the other technique. But I show this one because if you want to create fractions, you can create fractions. All right. To that end, all right, what we then see the more, all right, is more complicated fractions, but keep thinking to the main principles, all right, that we have been discussing, all right, for all of chapter 6 and 7. Before I even get going here, what do you see, and maybe what should we do to simplify our lives?
Move the y over, right?
Say again?
Nothing.
I didn't hear what you said.
Put it in descending order.
Descending order, that should always be one of our first steps, right? I see a couple pieces, all right, that are written kind of messed up. Okay, so descending order, and when you're looking at that, it's descending order in each piece. I actually have 6 expressions here. 1, 2, 3, 4, 5, 6. You need to look at each one of those and make sure, is that in descending order, right? That's going to be the most helpful to me. All right, don't get overwhelmed. I see 6 little small things. All right, so let's start. and put this in descending order. All right, then Kaylin, right, your favorite thing, what should we do?
Common denominator.
Okay, yes, that's absolutely where we're going. But, all right, when I look at those 6 individual pieces, like specifically like this guy and this guy, what do you see that's kind of messing us up? The negative. This is what you were always,
5 chapters ago.
to pull out that negative, right? If I pull out that negative, it is gonna flip the signs of both pieces, but then I have a positive y with everything. Whenever I can do that, it may help, it may not, but most of the time it's gonna help me. So this one has a lot of initial things that I might want to do first before I start doing common denominator. So getting all those negatives out front actually is pretty helpful. Mostly because if I have all of these are negative, I can divide the whole thing by -1 and it actually all becomes positive. So notice negative, a negative, and a negative. If you divide both sides by -1, they all become positive. While I'm at that, y squared minus 1. Do we see anything?
Is that perfect square?
It's a difference of squares.
Right.
So let's do this step because negatives are just always a hassle. And Brian, this is where you really want to pay attention because look, if I divide both sides by -1, look what happened. And sometimes just something simple like that, dealing with lots of additions is easier than dealing. Now, did I have to do that? Absolutely not. I could have kept those negatives and dealt with them as things progressed. But this is the difference between having an equal sign and not. When I'm solving something, do whatever you want to make it easier. As long as what you do to one side, you do to the other side. That's why solving is actually easier than simplifying. Because simplifying everything, make sure, you're multiplying by ones. Whatever it is, you're multiplying by a 1. But solving is just do to one side, do to the other side. And that's literally anything, as long as you do it to both sides. All right, so now, all right, so getting this set up is important to identify what the common denominator is. Because now looking at all those denominators, right? I had to pull a negative out of here. I had to factor this down. But now what's the common denominator? What is it?
Y minus 1.
Almost.
Y minus 1 and times y plus 1.
Yeah, it's actually both pieces, y minus 1 times y plus 1. This is basically 7 times 5, right? I got a 7 over here and a 5 over here, okay? This is not the same thing. This is its own number, okay? That's a number and that's a number, and these are 2 different numbers. That's missing the y minus 1. This one's missing the y plus 1. So in order to create the common denominator, this one is y minus one over y minus one. This one is y plus one over y plus one.
Could we do it by the y squared minus one, or would it add an extra fraction? We don't need to make it uneven. Because that middle one, that's like setting up the two terms, that was that difference of squares.
Yes.
We put that instead, or would it make it
Oh, can you just write y squared minus one?
multiply both sides by that instead, or would it add like an extra y something?
Ah, yep, that is the common denominator, y squared minus one and multiply by it. Yes, that's basically what we're headed towards.
Okay.
I was just trying to make sure we can identify what the common denominator is.
Okay.
But you're absolutely correct. I can multiply by the common denominator and eliminate it. All right, so what we end up with here. We end up with something that basically, we're gonna need to simplify this a bit, but, all right, I can multiply, essentially cross multiplying, and essentially what it is cross canceling. Those denominators will cancel out. Because if I multiply both sides by y minus one times y plus one, or actually just to emphasize, y squared minus one over one, y squared minus one over one. Cancel, 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 cancel. My fractions drop away. All right, and that all goes away. One. What do we get to do right here and right here? Box. Oh, look, you finally said box.
I didn't say foil. I did foil on my page, but I didn't say box.
So we got a couple of boxes to do to simplify this down. And since, again, all our fractions went away, all right, I have, all right, a simple integer equation to be solved. And we saw, in order to solve quadratics, what do? What do we have to get them equal to?
0.
0, okay, so keep remembering that. But, all right, I should always start by, let's combine our quadratics. So I'm gonna minus 2y from both sides. I'm gonna bring that 2y over. When I subtract 2y over here, I end up with 5y plus 3, and 2y squared minus 2y squared. Oh, look, the y squareds actually went away. So actually, I don't even have a quadratic. In one step, it all just disappears. And then now I can actually simplify this. Now this is just a linear equation, right? Get the y's to one side, numbers to the other, and solve away. Y equals 1. Oh, do you already see what happened? All looks good, yeah? All right, don't be fooled. We did 2 special cases today, Maddie, okay? All the way back to the top. What number can y not be? And, Just-
Zero, zero.
no, 0's okay.
And -1?
-1. If y is 1 or -1, I end up with zeros in the denominator. Okay? And I show that because 1, to make sure you're checking your denominator, but this is more rare than common. The solving, all those techniques, all right? But y cannot be -1 nor +1.
So it's no solution.
So it's no solution. That's why I was saying, don't get excited, because that's more the except.
Right, no solution.
Yeah, you're just gonna guess no solution from the start.
Yeah.
Not every question.
You're gonna look at me like,
This is, like I said, this is the exception, all right, not the rule. All right, and it's just fun because I want to make sure that you're checking this. If you recall, when we started chapter 7, the very first question that we actually asked is list all numbers for which the expression is undefined, right? And we found x cannot be -2 and 5, right, for this guy. That's basically what we're doing when you go to solve it. You have to check your denominators and see if it cannot be those values. But you still, right, you need to proceed through the solve because you have to see if what you solved is the same as the value that makes the number that makes the expression undefined. If they match up, then it's no solution. So that's what I'm saying. It's actually more rare, right? We just did 2 fun ones. All right, and again, all right, this is also what we did, right, in the 7.1, creating the common denominator all starts with prime factorization. Creating a least common denominator, this is an arithmetic skill. I cannot emphasize that enough. But fractions is something that people have just always ignored, okay? But fractions are crazy important. They're never going away. This is what our number system is, okay? So you have to be able to deal with a fraction, all right? Prime factorization is one of the best techniques to find common denominators. All right. That was the last one, right?